Good afternoon, everyone. Thank you for joining us for NET202, Designing Well-Architected Networks on AWS. I'm Andrew Gray. I'm a Principal Solutions Architect, and I'm joined on stage.
Hi, I'm Dmitry. I'm Senior Cloud Architect at AWS Professional Services.
I'm Radek Pododvorny. I'm Director of Engineering Platform Architecture from ARM.
All right. So getting started, a couple notes here. This is a 200-level course. So we do expect you to understand the basics of what VPCs and subnets are. We're not going to go that level, but we are going to be focused on how do you do these in a well-architected manner. How's the best way to deploy it? What are the tips and tricks? Throughout the presentation, there are a variety of QR codes. Feel free to take a picture of these with your camera, or after the session, you'll be able to download a copy of these slides, so you can get to them then. These will point to other sessions or white papers or other bits and pieces that are of interest for these individual topics. And finally, watch out for our well-architected cat. This guy has a number of tips and tricks as we go through the presentation, and these are our best tips for doing networks in a well-architected manner. So, Dmitry?
Thank you, Andrew. All right, let's start with the basics of networking on AWS. AWS global infrastructure consists of regions and availability zones. So we have more than 30 regions interconnected with high-throughput backbone. And every region is at least 3 availability zones. Every availability zone, or AZ, is at least 1 data center. AZs are not very far from each other, so that we have low latency supporting synchronous data replication, but they're also not very close to each other. So in the events of power outage or natural disasters, we don't bring down 2 AZs at once. Amazon Virtual Private Cloud, or VPC, is the main networking construct on AWS. It's an isolated network segment. It is a regional construct, and we can assign one or more IPv4 or IPv6 CIDR blocks. Inside of VPC, we have subnets. So subnet is an AZ-level construct, and we can have dual-stack subnets, we can have IPv4-only subnets, we can have IPv6-only subnets. This is our first appearance of our cat, and she has a couple of tips for you. We do recommend dual-stack approach, and also minimizing cross-AZ communication if possible. There will be lower latency, less costs, and less risks. Lastly, in the multi-account setup, we do recommend using AZ IDs, like USE1, AZ1, 2, and 3, instead of AZ names, because AZ names can be different in different accounts. And now let's talk about internet access for VPC. So in order to have communication to and from the internet for IPv4 or IPv6, we use a construct called Internet Gateway, or IGW. We call a subnet public if there is a route to the Internet Gateway, default route to an Internet Gateway. And for IPv6, we don't need to configure anything extra. So as instance with IPv6 address, we'll be able to communicate via Internet Gateway with the internet. For IPv4, though, we need to use additional construct called elastic IP address. It's public IP address, which when the traffic goes through an Internet Gateway will perform source network address translation or not, from private IPv4 address to elastic public IP address. With public subnets, though, the communication can be not only initiated from you to the internet, hosts on the internet can initiate connection to you. So what if you don't want that? For that, we use private subnets. For IPv4, in order to still be able to do outbound internet connectivity, we place an NAT gateway in the public subnet. For IPv6, we would create another construct called egress-only IGW. By setting up corresponding default routes for IPv4 and IPv6, we will achieve this private subnet functionality where we can initiate connection outbound, but connection inbound cannot be initiated to you from the internet. We have just released a new feature called VPC block public access, and it's a new data plane control for connectivity to and from the internet. It has several modes, and you can set up an exclusions. In this case, if I set up an ingress-only mode for BPA, the connectivity to this top-left instance from the internet will not be allowed, but the outbound connectivity through a NAT gateway will still be allowed. A couple of tips for you. We do recommend creating a NAT gateway in every single availability zone. You would want to prefer using private subnets and place most of your resources in the private subnets and put only necessary resources in the public subnets, such as internet-facing load balancers or NAT gateway. And lastly, you would want to use VPC block public access for additional compliance. Next, what if we have an IPv6 subnet and IPv6 only hosts, and we want to communicate with a host on the internet which uses IPv4 only? We can use DNS 6.4 and NAT 6.4. First, we enable DNS 6.4 on this subnet level. This will make DNS resolution from Route 53 resolver return the special DNS 6.4 IPv6 address, which encodes IPv4 address. We set up an additional route towards the NAT gateway for this specific DNS 6.4 prefix. And when NAT gateway will receive this traffic, it will convert this IP address back to IPv4. This way, we can make this connectivity between IPv6 only hosts in VPC and IPv4 only hosts on the internet work. Let's talk about health checks on our load balancers. So load balancers do health check your targets. So it's very important that you set up proper health checks for your application that actually tests the health of your application. In addition to that, Route 53 will also do health checks of the load balancer nodes themselves. So in case there is a problem with either a load balancer or all targets behind a specific load balancer node, Route 53 can remove the load balancer node from DNS resolution. Okay, let's talk about Amazon Application Recovery Controller, or ARC. This is my most favorite networking feature on AWS. So we have our application behind a load balancer, and we set up a monitoring, and we started noticing that the latency for one of availability zones is higher, or we have an increased rate of errors. We can ask Application Recovery Controller, or ARC, using an API call to start a zonal shift. So the node of the load balancer will be removed from DNS. So we take AZ out of service. Couple tips for you here. If you want to do this, you need to make sure that you pre-provision capacity. So this means that if we evacuate from a particular AZs, all other AZs can handle the spikes of the traffic. You would want to test this regularly, so in case of outage, you can be sure that it works. But something in addition that we released quite recently is zonal autoshift. With zonal autoshift, AWS can do this zonal shift on your behalf. And we have recently announced that now we support ARC zonal shift for both ALB and NLB with cross-zone load balancing enabled as well. All right, if I have more than one VPCs, how can I connect them together? Andrew, could you help out?
Sure. So AWS has a huge number of these ways to connect VPCs, and I'm going to go through most of them and give you the tips as to when to use them and how to use them. The first one that tends to come up is VPC subnet sharing. Subnet sharing has an interesting history with customers because there's a lot of confusion about what it is and how it works. So in this simple example here, we've got 3 accounts, we've got a VPC, and we have a subnet. This is the thing that we're sharing, and we're sharing it across the different accounts. Why would we do this? The usual use case is where a centralized networking team wants to set up and control aspects of every subnet. In this case, interface endpoints or Route 50 resolver or whatever it is they're doing. And then they effectively grant permissions to these other accounts to deploy resources into those subnets. A couple of things to be aware of. This is not multiple VPCs. You do lose some of the capabilities of the VPC isolation by doing it this way, but you gain those abilities I mentioned earlier. And just as a note, make sure everything that you want to deploy inside a shared subnet is actually supported. Some AWS services aren't. The next one is also very common. It's VPC peering. VPC peering is we set up a connection in 2 VPCs and effectively tie them together. This interaction is very, very close to making these 2 VPCs act as one. It is a great option in a smaller subset of scenarios. The main issue to be aware of is you have a small number of VPCs to connect. You can only have 125 peering links inside a VPC. There's also additional limits as to how big a group of peered VPCs can be. So this isn't intended to be a monstrous global way of being able to do VPC communication. It is, however, useful in certain situations or if you're doing cross-region work. You can use VPC peering if you need the highest bandwidth or lowest latency possible. Remember I mentioned this is like merging the 2 VPCs together, so a lot of the quotas that you see with other AWS networking services aren't in play. But keep in mind, you do lose some capabilities here. You lose the ability to easily do inspection or run things through centralized communications or firewalls or what have you when you do this architecture. Next one up is Transit Gateway. We won't go too terribly deep into Transit Gateway. It is AWS's cloud-native, highly redundant, highly scalable cloud router. But what I do want to talk about is all the different ways that you can use Transit Gateway. You can set Transit Gateways and their VPCs that connect to Transit Gateways in any number of combinations and form a wide variety of topologies. While full mesh is probably by far the most common, you can do things like individual silos. You can implement centralized inspection. Anything that you would normally associate with being able to do in terms of router controls, you can probably do on Transit Gateway. So don't just think it has to be full mesh. We have a lot of customers that do different topologies, just depending on what their specific requirements are. There are a couple notes when you do deploy Transit Gateway. First off, AWS strongly recommends that the TGW attachment that you'd have to deploy in every VPC in order to communicate with Transit Gateway gets put into its own dedicated subnet. A lot of customers will try and put this into the same subnet as other resources, but this causes issues if you want to go through and add more specific routing or what have you. Having that separate subnet, and particularly the separate route table, is very helpful and leaves you options in the future for being able to do more advanced networking concepts. Secondly, make sure to put a Transit Gateway attachment in every AZ that you're actually using. We have seen a lot of issues where customers deployed it only in one AZ and thought that was sufficient. An instance cannot talk cross AZ to a Transit Gateway attachment. It has to have one in the local AZ. So make sure you do that. The next construct up is Cloud WAN, and Cloud WAN is relatively new, coming up in the past couple of years. But Cloud WAN is another function where you can do cross-region communication, but instead of individual attachments, Cloud WAN focuses on the concept of a segment. This is a very useful feature if you ever need to define in relatively straightforward policy, the core network policy, how these segments interact with each other. You no longer need to worry about specific routing tables or what have you. This is helpful if you're interacting with a security group that says, hey, development can only talk to prod in these small number of circumstances. Or I have prod US and prod EU, and they're only allowed to talk to each other in certain circumstances. You can define all that in JSON or what have you inside CloudWAN with that policy document, and it handles the setting up of the routes for you. You can also do an inspection segment, so you can use CloudWAN to implement both north-south, i.e. from workload out to the internet, or east-west between two different VPCs inspection inside CloudWAN, and even do it multi-region. CloudWAN handles all that for you. Also, just recently released, Direct Connect is now officially supported, going directly to CloudWAN. Previously, you used to have a transit gateway that would terminate the Direct Connect connections. AWS just announced this in the past week, couple days, something like that. This is now very helpful because it helps even simplify that. A couple tips from our cat. Don't be afraid to add more segments. Don't try and force things into 1 or 2 or 3 segments. I have many customers that are using 10, 15 segments just because of different research groups they want to keep isolated, things along those lines. And like I said, CloudWAN makes inspection easy. If you're wanting to do this, take a good strong look at CloudWAN. The next option up is VPC Lattice. AWS has talked a lot about VPC Lattice in the past year, but still find that networking folks tend to be a little, what is this thing? So at a high level, let's imagine we've got 2 VPCs, a client and a server, and we have client and server instances inside there. We want these to talk to each other. What we can do is we put both VPCs as part of what's known as a Lattice service network. This is a control plane construct. There's no physical thing here yet. We then deploy Lattice endpoints into each of these VPCs. Now I don't need transit gateway or anything else, because now what can happen is a server will register with Lattice. It says, hey, I'm providing service logging, authentication, lolcats, whatever it is that you want to put out there. And it'll also say, hey, Lattice, please enforce these authentication requirements, which it will do. Clients will then go through and say, hey, I need service XYZ. Here's my authentication credentials. And Lattice will accept that request and allow that traffic to go through. You don't need any other networking constructs in order to do this, and you completely isolate what the server is versus what the client is. And that's the power of it. You can have the server, same VPC, different VPCs. You can have it spread out across multiples. VPC Lattice is well suited for HTTP, HTTPS, gRPC type of applications. And also new, just released yesterday, you can now add service network endpoints, which means you now have an endpoint that you can talk to from things like off-premise into your VPC Lattice network. This is very handy for being able to go into these constructs that we've built. The next VPC endpoints, when we talk endpoints, we talk private link. Private link allows you to deploy interface endpoints into a VPC, and you can set those endpoints to be a direct route to an AWS service, for example. Over 150 of them support private link. You can also go to another VPC. We see this happening a lot with software as a service or even your own internal services. It just has to have a load balancer behind it. And that VPC can be in a different account. It can have address overlaps with your original VPCs. And also, just newly announced, it can now also be in another region. We announced support for cross-region private links. There are also gateway endpoints, which allow you to talk to S3 and DynamoDB. And the 2 big points here are use the gateway endpoints when you can. They're free. You don't pay for the charges on them, as opposed to interface endpoint. But interface endpoints allow you to have this direct connectivity, and you don't have to worry about the intermediate data processing costs that you might have with transit gateway or NAT gateway or whatever else you might have in the middle. Very handy. AWS also just recently announced the concept of resource endpoints. And resource endpoints seem a fair bit like a merger between private link and Lattice. What resource endpoints allow you to do is now you can target IPs, DNS names, or RDS-HARNs, and you don't need a load balancer in front of them anymore. You can define them all as resources that you extend into the VPCs. Resource endpoints are Very, very useful for when you don't have the load balancer. If you're looking at meshy protocols, Kafka, things like that, very, very handy for those types of workloads. So keep in mind, there are many ways to tie together these VPCs. I strongly recommend you figure out an 80-20 rule. Find what handle the 80% of your traffic, and then be ready for private links or lattice or whatever else you might need as an exception. Don't try to squeeze everything into one, but also try to keep some guardrails around. Don't just let everything happen kind of in the wild. I've talked a lot about inside VPCs, but let's talk a little bit about when you should go multi-region. So if we start off with an application that is well designed, we have 3 AZs, we've got our load balancers in front of it, we have a DNS name that points to those load balancers, and this is all great. This is what we'd like to see for an application. Adding in a second region at the top is just as easy as you deploy a copy in a second region, and then you update Route 53 to point to the resources in that second region. A few notes about this, though. Route 53 offers a lot of interesting ways to steer that traffic. You don't have to round robin it all. Route 53 allows you to determine based on latency between the clients and the endpoints, geolocation, geoproximity, both ways to allow determination of where the client is and send it to the region. This gets useful if you want to steer, for example, US customers to US regions and EU customers to EU regions, things along those lines. The multi-region, you would use that to, like I said, reduce latency, improve availability. Just remember that as I go through the multi-region constructs, the transit gateways and such I mentioned earlier, you cannot go through China. China is a separate partition inside AWS, so it's off in its own area there. Transit gateway is one of the services that do allow you to go cross-region. And the main point to keep in mind here, and the number one question I get asked is, does this traffic leave the AWS backbone? It does not. We do not route that traffic over the internet or anything like that. So if you're doing TGW peering or Cloud WAN, whatever you want to do between regions, that traffic stays on the AWS backbone. However, be aware of latency. Application folks get used to same AZ or same region, different AZ latencies. Multi-region gets much higher. Fortunately, AWS gives you the tools to see just how much higher that is, and that's the infrastructure performance tool. If you haven't seen this yet in the console, it's pretty interesting. It does allow you to see what AWS is measuring as the latencies between our regions and even our AZs. And you can go in here and select whatever combination you want, and you get a very nice chart of those latencies in milliseconds. I've talked a lot about now going between VPCs. Let's talk about to data centers. Customers almost inevitably start off with site-to-site VPN. It's an IPsec tunnel. You can configure it between a router and firewall on your side and a VPC on our side. Nice, clean, easy, straightforward. One note, though, is when you go to configure it, you'll see there's options for Tunnel 1 and Tunnel 2. Please configure both. AWS does maintenance on our side fairly often, and if you have both tunnels configured, that will allow the device on your side to fail over between tunnels and reduce the impact on your side. However, this only protects against the failover on the AWS side. On your side, configure a second set of tunnels going to a separate device to truly get your redundancy up there. Customers will tend to go from site-to-site VPN to Direct Connect. And a lot of questions about Direct Connect and the VIFs that are involved. Direct Connect is a fiber link that's between you and AWS, and you can put multiple VIFs on it. When do you use what VIFs? Private VIFs go to one or a small number of VPCs directly. The transit VIF is used if you do a transit gateway, and this is the route most customers are going. They'll go to a central transit gateway, they'll have a transit VIF that provides that connectivity. The third one that gets forgotten about a lot, though, are public VIFs, and there's a bit of confusion on these. Public VIFs give you a connection to the AWS public backbone. This means you can access AWS services that have public IPs. You can also access other customers that have public IPs. So treat this connection as external, because it is. There's outside orgs that could come in through it. It does not give you direct access to the internet, however. It is only to AWS public resources. Finally, most companies and most deployments only need one Direct Connect gateway globally. Direct Connect gateway is a purely control plane aspect. Your data doesn't go through it. It is close to a route reflector. You don't need ones. I've seen incidents where customers have deployed one for every VIF. You don't need that. Finally, the direct connect resiliency. A lot of questions I get around this. And there are 3 levels. The first one is development and test, single connection, where you have one or a couple connections, but it's a one-to-one location. The next level is high, where you have 2 locations, but still only single links in each direction. The last is maximum, where you combine all these together. And that is where you can get the highest SLA, where you have multiple links in multiple locations. Keep that in mind when you're designing what your SLAs are. Encryption always comes up. Keep a note, AWS does protect all the traffic going between our facilities, so you don't really need to worry about that too much. And if you're worried about it on your Direct Connect side, a lot of our sites support MACsec, which is a layer 2 encryption on Direct Connect. If that's something that's beneficial, there's your option for it. You can also do IPVPNs over your Direct Connect link. You can go to private IPVPN on Transit Gateway and terminate it there, or you can do site-to-site VPNs that terminate on your VPCs all over Direct Connect. However, application-level encryption, TLS, is frequently a better solution than worrying about any of this. Finally, keep in mind you can back up Direct Connect with VPN. And remember, from our CAT, when it comes to connectivity, 1 is none. 2 is 1. Dimitri, I've talked a lot about IP addresses, and I'm told humans don't like numbers, so what can we do for that?
Thank you, Andrew. Let's talk about domain name system, or DNS, and how to design it properly on AWS. Let's say we have an instance in a subnet in VPC, and if you don't change any settings, by default, that instance will use Route 53 resolver. It's highly available and scalable DNS resolver available for you inside of VPC. It's also available on VPC +2 IP address. And by default, it will resolve any public DNS queries. But what if you want to have some kind of special domain that is used internally? We can set up a private hosted zone, in this case, for domain aws.internal, and have any kind of records inside of it. When we associate a VPC to this private hosted zone, the Route 53 resolver for that VPC will be able to resolve records from this private hosted zone. OK, what if we have custom DNS servers? It can be on premises, but it can also be other DNS services on AWS, for example, Active Directory. Well, in order to achieve hybrid DNS resolution here, we will create outbound Route 53 resolver endpoint, and then create associated resolver rules, which will say for a particular domain, we will forward DNS query to a particular DNS server. It can be IPv4 or IPv6. Then this resolver rule can be RAM shared across your organization, and your VPC can be associated to that resolver rule. When you do this, Route 53 resolver will forward DNS queries for specific domains to the DNS servers that you specified inside of resolver rules. For reverse DNS resolution, and when we want to resolve some kind of DNS queries, let's say inside of private hosted zone on AWS, from your on-premise DNS server, we can create an inbound resolver endpoint and do appropriate configuration on your DNS server to forward queries to AWS. OK, let's talk about anti-patterns that we sometimes see. So first one is overriding the default DNS server using DHCP option. So let's say in this case we have 2 other DNS servers, and we will change the DNS server using DHCP option. So first, your first DNS server in the list will be highly utilized. All of the load will go through. You'll have cross-AZ traffic, which means additional latency, additional risks, additional costs. So we generally don't recommend overwriting the DHCP option, and we strongly suggest using default VPC +2 resolver. Another anti-pattern we sometimes see is when we send DNS traffic from outbound to inbound endpoint. So we have 2 sets of these endpoints in, let's say, shared services VPC. We associate a private hosted zone to this shared services VPC, but then we create a resolver rules for different domains where we send traffic from outbound to inbound resolver endpoint. This also has cross-AZ traffic, but there will also be additional costs for all of your DNS queries going through these endpoints. So in general, this is not a recommended approach. Okay, how can you make your DNS configuration consistent across a whole organization, across a whole VPCs? So we will take our private hosted zones, we will take our resolver rules, we'll take query logging, which will log all of the DNS queries going through Route 53 resolver. We can also add DNS firewall, which will block or allow specific DNS queries. We can bundle this all together in Amazon Route 53 profile. Then we will RAM share it and associate to every single VPC in your organization. This way, you will make sure that if you make any changes to your DNS configuration, they are propagated to your whole environment. A couple of takeaways here for DNS. Don't override default DNS server. Use resolver endpoints for hybrid DNS resolution, and you would want to set up rules for domains using resolver rules. Use Route 53 profiles to keep DNS configuration consistent. And now let's take a look at network security on AWS. And I want you to think about it as a layered approach. So there are different layers and there are different services on AWS which can help you out here. So inside of VPC, you have security groups and network access lists, or NACLs. Security groups are distributed, stateful firewall, which is present on most of the network interfaces. Network ACLs, in contrast, are a stateless firewall between your subnets. In general, you would want to minimize using network access lists because it's really hard to manage. There are some limits on the number of rules, but also dealing with ephemeral ports is actually quite hard. But with security groups, you want to leverage them as much as possible. On the VPC boundary, we can add an additional firewall. And it can be AWS managed firewall, for example, AWS network firewall. Or you can also bring your own third-party firewall. And you can do this using gateway load balancer in front of that firewall and gateway load balancer endpoint. And we already covered Route 53 DNS firewall, which allows you to block or allow specific DNS queries. Next, specifically for your web applications, you would want to use web application firewall, which will protect you from common web exploits, for example, top 10 of OWASP. You can even set up some rate limiting rules. If you need DDoS mitigation, you can use AWS Shield, and it comes in two flavors, standard and advanced. And if you want to manage your security configuration across your whole organization, so it can be security groups, network access lists, WAF web ACLs, network firewall policies, you can use AWS Firewall Manager. I want to spend a little bit of time specifically on security groups cross-referencing. It's very powerful, and we strongly recommend using that. In this case, we have an application with 3 layers. There is load balancer, there is instances for the application, and there is database. And for every one of those layers, we define a particular security group. Now, we will configure security group rules, but to allow appropriate communication between these layers. But if you take a look at this, we almost never use IP addresses here. So this is very powerful because you don't have to deal with those IP addresses. But even more important, if you have some kind of dynamic IP address, for example, new load balancer node or new auto-scaled instance, you don't have to make any changes to your security groups. And now we have been supporting cross-referencing for SGs for VPC peering for quite a while, but now it's also supported across transit gateway. So please use this to scale your security groups rules management. All right, let's talk about probably my favorite topic with customers, which is traffic inspection patterns. And there are typical use cases for a firewall. So first one would be VPC to VPC inspection, or sometimes referred to east-west inspection, egress filtering, and ingress filtering. Let's take a look at every one of those. So for east-west, the thing I would like you to think about what would be the actual use case. What is the security outcome that you want to achieve if you want to do that? So there are, if you put a firewall, what exact configuration you're going to deploy? You will probably have your traffic encrypted. So what exactly will be there on the firewall? And there will be also cost considerations. If you send all of the traffic through a firewall, it might get quite expensive. For dynamic IPs, for example, maybe security group cross-referencing will be a better fit because you don't have to change some kind of firewall rules. And also, you might want to consider zero-trust approaches where you do some kind of authentication and authorization on the application layer itself. So with services like Amazon VPC Lattice, they can help you achieve that. OK, let's talk about egress. So when your workload wants to go out to, let's say, the internet, we need to think about IPv4 network address translation. We might want to think about your security and specifically egress domain filtering. And services like NAT Gateway and AWS Network File can help you with this. But the question is, where do you put them? All right, so the first model for egress would be centralized egress. So in this case, you will take a firewall endpoint and a NAT gateway. You create a special VPC for it. Let's call it centralized egress, and you will put it there. Then you will connect this egress VPC with all of your other VPCs using transit gateway. So this is a very common approach we see customers do. So it's very easy to set up and manage. And you can even reuse that firewall endpoint for east-west. But you need to think about cost here. So you have a low number of firewall endpoints, low number of NAT gateways, but now you will have an additional transit gateway data processing charge. And specifically for IPv6, centralized egress would require either proxy or NAT66 solution. OK, so alternative to this would be distributed egress. So in this case, we will put firewall, endpoint, and NAT gateway in every single workload VPC. So the main benefit is that now we scale independently from other VPCs. We limit this blast radius only to a single VPC. It is native for IPv6. But again, you need to think about costs. So in this case, now we have a high number of firewall endpoints, high number of NAT gateways, but you no longer pay for transit gateway data processing. OK, let's talk about ingress. And this is probably one of the most controversial topics we have. All right, so how do users access your application securely? You would probably want to have some kind of firewalling capabilities there. All right, so the first pattern is centralized ingress. And in general, there are many variations of it. In general, we see two sub-patterns here. One is transit gateway. So in this case, we have centralized ingress VPC. We put a firewall there. We have a load balancer, internet-facing load balancer, maybe with web application firewall. And then in the spoke VPC, we have another load balancer with your workloads. Another variation of this is instead of transit gateway, you use private link. So this is a little bit better because you will, for isolation purposes, and the cost will be a little bit lower. So now the VPC on the left and on the right are actually isolated, and you specify only a particular communication for that particular service. And you can also put a firewall before or after load balancer, and there are different trade-offs for both of these. OK, so what does our cat have to say about this? So many customers like it because it's similar how things have been done on premises. It's DMZ-like approach. You'll have also centralized public certificate management in a single account. But there are a lot of drawbacks. So first, you have your different applications with different needs, but all of your applications will be in this central place, which don't really make sense because they are different for different applications. Another thing is your firewall might need to decrypt TLS for inspection and then re-encrypt it again. You will also need an additional load balancer in your workload VPC if you want to have some kind of auto-scaling. And this option will be also much more expensive. OK, so alternatively, we can do distributed ingress. So in this case, in every workload VPC, we'll create an internet-facing load balancer if you want users to access our application from the internet. We can add a web application firewall there. We can add firewall for additional layered protection. We can also add a CDN like CloudFront for caching and additional protection at the edge. And we can add Shield for DDoS mitigation. So this is a cost-effective solution. In general, we strongly recommend going with distributed ingress. Your application-specific configuration will be all together in one place. You have limited blast radius here as well. So if you have a misconfiguration, it will not affect your other applications. You can use WAF to protect your web applications. You can add a firewall for additional layered security. But you will need to think about automation on how you can satisfy compliance and governance in all of these different accounts and different VPCs. A couple of takeaways here. So for egress, both approaches are good. So centralized and distributed are good. For IPv6, you would probably want to use distributed egress to avoid proxy or NAT666 solution. For ingress, we recommend distributed approach. You can use WAF to protect from web exploits. You can use AWS Network Firewall for additional protection. You can use CDN like CloudFront for caching and protection at the edge. And you can use Shield for DDoS mitigation. With all of this information that we covered today, let's go back to our VPC block and things you need to think about when you design your VPCs. So you want to start with understanding how many AZs you're going to use. You would want to identify your routing patterns and how you group your different workloads and instances for firewall rules. You'll want to understand, maybe even write down the number of IP addresses you need in every subnet and leaving some room for growth. And your different workloads might actually have different sizing needs. Maybe if you're using containers, you need thousands of network interfaces, so that VPC will be much bigger. For IPv6, the IP planning is just so much easier. Almost every subnet is /64. There are a number of VPC sizing considerations that you would want to look up in this documentation page that you need to take into account. OK, so if we want to implement this infrastructure at scale, you would want to use some kind of infrastructure as code tools to create patterns and templates for your infrastructure. So here is an example of how you can do stack separation for your infrastructure as code. So you may have a stack for IPAM scopes and pools. You can have a stack for Cloud One or Transit Gateway infrastructure. You can create a module and stacks for different regions for your DNS configuration with Route 53 profile. You can have a module for your specialized VPCs, maybe centralized egress, shared services can be its own module. You will want to create a module for your workload VPC where you capture all of your design decisions, where you can combine things like VPC, subnets, route tables, internet gateways, flow logs configuration. You can add their Route 53 profile association. You can add creation of Transit Gateway or Cloud One attachment. And lastly, you would want to have a stack for your application itself. So it will be instances, load balancers, security groups. All right, and now let's hear from Radek about ARM's networking journey on AWS.
The engineers I'm working with are developing one of the most successful products in the current world, ARM architecture. Product so successful that currently is consumed by 70% of entire human population. My role is to take AWS services, embed it into solution, take this solution and build complex environments and share these environments with engineers to support the job they are doing. Ladies and gentlemen, my name is Radek Podedworny. I'm Director of Engineering Platform Architecture. Let's get started. For the next 15 minutes, I will take you to the journey to the cloud. ARM started 6 years ago. I will tell you about the services we have adopted. I'll tell you about the solutions we have developed, but also decisions we have made. Decisions that allows us to be today precisely in the place where we wanted to be in the beginning of this journey. Since the beginning, we knew that we will consume AWS in multi-region, multi-account environment. We built our backbone based on regional transit gateways in fully meshed scenario. In this case, traffic between region A and region B always use the shortest path and always hits 2 transit gateways. The more workflow we moved to the cloud, the more dependency we have discovered that they are outside the cloud, mostly in our data centers. So natural way was to build a secure connectivity between our data centers and cloud, and we deliver this as a site-to-site VPN, multiply site-to-site VPNs terminated in regional transit gateways. It worked quite well, but it created a very interesting challenge, and I believe some of them have this challenge as well in your companies. We had 2 teams, networking team, responsible for overall networking in the corporation, and cloud team, who has some skills, also networking skills, so we wanted to draw demarcation line between these 2 teams. We took appliances which we're using on-prem, we virtualized these appliances and deploy in the cloud, and we built site-to-site VPN, one group of site-to-site VPNs between the virtual appliances to the data centers and another between virtual appliances and our transit gateways. It works quite well, but it created some performance issue, especially on these virtual appliances. So we had to find some solution how to replace both sides of VPNs. First VPN has been replaced by transit gateway connect attachment, and the second group of VPNs has been replaced by direct connect, which for the first year was used as a medium to transfer data, but in 1 year we improved this and we use this as a fabric to build SD-WAN solution delivered by one of our partners. And now we did a full circle, and we again focused on our AWS environment. We are enrolling Cloud One. Cloud One is a natural successor of multi-transit gateway scenario, but also solution which allows us to shape our networking using code, which is extremely useful if you want to drive automation. Before we even started to do anything with our infrastructure, we started to plan IP, and we plan IPv4, IPv6. I will tell you about both sides, but please be aware that IPv4 has been planned in the beginning of this journey. IPv6 has been planned 2 years later, and you will see how the requirement has changed. Anyway, for IPv4, we wanted to be present in 4 main regions. We wanted to have ability to address 100 plus VPCs in each region, and we wanted to be highly available to availability zones. And we thought that using /24 per VPC is a good entry point for a discussion. As a result, we took /15, we delegated this into 4 /17s per each region. Inside each region, we have divided the /17 into 128 /24 per each VPC, and every single /24 has been divided into 2 /25s per availability zone. 2 years after, we decided to start using IPv6, and the requirements were completely different. We were no longer interested to be in 4 regions. We wanted to use 16 regions. We are no longer interested to have 100 VPC. We wanted to have 4,000 VPC, and we are no longer interested to have only 2 availability zones. We wanted to consume all availability zones, and you know, as Dimitri said, the number of availability zones varies per region. As a result, we took /25 IPv6. We took 42 from this 25, which has been dedicated for AWS. We sliced this in 16/36 per each region. Each 36 has been sliced into another 4,096, 48 per each account. Each 48 has been divided into 256, 56 per each VPC, and each VPC has been divided into 256, 64 per each subnet. IP addressation is one thing, but the second thing is the shape of the account which we are using, which our customers, our engineers are using. And of course, every single project when we discussed with engineers was quite unique, and they have some quite unique requirements about the networking shape. But on the other side, from operational perspective, we were interested to deliver some templates which can be shared with current and future project. And we developed 3 patterns. We call it flavors. First pattern is a fully routable from ARM. It's nothing special, 1 VPC, relatively small, /24, fully routable from our data center. The second is a partially routable VPC, and here we've got 2 seeders. One seeder is a relatively small seeder, fully routable from ARM, and the second is quite huge seeder, limited by AWS quota, visible only inside VPC. It's absolutely okay, because we are doing a lot of high-performance computing, and high-performance computing required for us have a lot of IP addresses which can address nodes which does not require direct connectivity from the outside VPC. But the third pattern is very interesting, and as you can see, third pattern is a copy and paste from the situation we did with the networking team. So we've got /17, which is dedicated to regional transit gateway. We took from this regional transit gateway /20, which we dedicated to project transit gateway, and we're allowing people in the project team to slice this IP pool wherever they want. As you can see, they have 2 accounts, one account with one quite huge VPC, and they took /21 for this, and another account with 3 VPCs, /24 per each VPCs. And on top of this, we've got another account which has completely different IP addressation, which is peered using VPC peering. You cannot think about hybrid cloud if you don't have hybrid DNS. And this is something which Dimitri mentioned about. We also follow the AWS best practices. We've got set of inbound endpoints. We've got Route 53 rules. But we want to go a step further. We want to allow, and we allowed our users to shape this DNS based on the needs. Every time when new spoke account is created, all Route 53 rules are shared with this account. But then, inside the account, there is an AWS Service Catalog product which allows to create private hosted zone. Private hosted zone 1 created is automatically associated with hub account. And in this case, all DNS zones, all DNS domains, including this one which we have just created as a part of this product, is resolvable not only within single spoke, original spoke, not only across all spokes in AWS, but also from our data centers. And another thing, in journey to the cloud, there are a lot of situations where AWS services, where we've got some requirements which cannot be covered by AWS services directly, and we had to build automation. And this is one of the examples. We've got max preservation. So we've got some use case where EC2 instance, after destroying, it needs to keep the MAC address. And it has been solved by creating independent interface, which will be automatically detached and attached to EC2 instance. We built this automation using auto-scaling group. Auto-scaling group as a service which keeps this auto-healing capabilities, so recreate EC2 instance every time when it needs to be created. Lambda function, which is responsible for attaching the detaching interface, and code deploy, which deploys all software. Remember, we were talking about end-to-end automation. So in this case, I'm not only interested to have new EC2 instance with the proper interface, proper MAC address, but I also would like to have all software installed on this. And to be honest, this architecture has been also extended by flow number 7. If we would like to update existing one EC2 instance without destroying this, we can use this by combination of object store, code deploy, which is orchestrated by AWS code pipeline. Now, I would like to repeat everything and conclude everything what has been said. And I used, for this, I will use some quote from ancient Greek philosopher, big results require big ambitions, and I'm absolutely sure nobody disagrees with this. What I would like to add is that big results required some vision, required some plan and decision. Vision, which tells you what you're trying to achieve, plan, which will tell you how you are planning to achieve, and the decision, which allows you to navigate through plan to achieve the goals highlighted in your vision. Ladies and gentlemen, my name is Radek Podedworny. I'm Director of Engineering Platform Architecture. It was a pleasure to be here. Thank you.
Thank you. So let's summarize what we've all talked about and how to think like an AWS networking architect. First off, planning is important. Planning your account structure, your VPC structure, making sure that those are sized appropriately for not only what you need today, but what you're going to need in the future. We heard about ARM's journey, how they had to rethink things, but even in just the 2 years between the V4 and the V6. Be ready for that. Once you start deploying into AWS or wherever, you'll find that requirements change and can change fairly quickly. Plan your IP addressing, ASN numbers, all that sort of thing. Avoid overlaps if you possibly can. IPv6 makes this much, much easier to avoid IP address overlaps, but think about it even in the IPv4 world. They're tricky to deal with and could be an unnecessary complication if you plan it out ahead of time. Plan what you're going to do for your cross-VPC connectivity services. Most customers will do transit gateway and then cloud WAN, like we saw from ARM, to do the bulk of their connectivity work. But keep in mind the other services that we talked about, the private links, the lattice, resource endpoints. All those sorts of functions, keep them in your back pocket. They're very handy tools for solving some particularly thorny problems that you may come across. Make sure you understand, you have defined, and you have designed around your expectations for your connectivity to on-prem data centers, if you have them. We've talked a little bit about SLAs and IPsec tunnels and direct connect, and you have a lot of tools in order to build the connectivity that you need. And it may not just be SLA related, it may be location related, it may be any number of factors. But sit down and think it through and make sure you truly understand what it is that you're designing towards, and don't just go for the maximum 9s you can get. You may not need it. For DNS, you use the Route 53 resolver or the VPC +2 resolver. Unless you truly have a very specific use case, Route 53 is highly redundant, highly scalable. It is there to be used. Use it. For when you are doing the Route 53 resolver, the Route 53 profiles that Dimitri talked about, these are huge for helping to ensure that you keep your deployments consistent. And as anyone who's done operations work will tell you, keeping things consistent is very, very helpful to avoid people from freaking out at 2 o'clock in the morning while they're trying to figure out what it is that's special about this particular VPC. Make sure you understand and plan around the security capabilities of AWS. Don't just throw everything at it. You may be, have a security group that says, oh, we want firewalls here and there and there and everywhere. Think about what you're actually trying to do from a security perspective. Are you actually interested in deep packet inspection, intrusion detection? Or are you just trying to avoid, geo-blocks? Or what are you trying to do? Get down to that level of detail before you plan out your security strategy. Finally, evaluate the different traffic inspection patterns that Dimitri talked about. Centralized versus decentralized, not one size fits all. If it did, we'd have it in a golden guide. We do recommend a couple other sessions here at reInvent. The follow-up to this one is NET201 later today. This is where we talk about the advanced design and some of the additional new features. And then NET403 talks about planet scale networking. Really interesting sessions. I encourage you to watch them if you can't get into them today. Thank you all for joining. I'm Andrew Gray. We've had Dimitri and Radek. We will be outside to handle questions and answers, so feel free to tap us on the shoulder. Otherwise, thank you all for joining. Please fill out the session survey at the end, and thank you very much.